Hello, Hiba.
Good evening, sir.
Good evening. So, in the last class, we discussed velocity in general motion. So, what is general motion? When the body is rotating at the same time and moving linearly at the same time, like this. Okay, it is moving, rotating also, and moving linearly also, like this. That is the general motion. So, we were discussing the velocity in general motion. So here, this is the case. Here you can say this is a disk, and this disk is moving with a velocity v linearly. This disk is moving with a velocity v linearly, and also at the same time, this is rotating with an angular velocity of omega. And this velocity v is the velocity of the center of mass of this disk. Okay. So there are different points or different points on of this disk. So we have taken 4 points to define the velocity O, P, M, N. So suppose, for example, this disk is moving with a velocity v and moving linearly with the velocity v, and at the same time, it is rotating also. It is rotating also with an angular velocity of omega. So in this case, v is the velocity of the center of mass, and I told you this velocity will be provided to all of the point. This velocity will be provided to all of the point. Means this O point will have this velocity, P point will have this linear velocity, M point also, N point also will have the same linear velocity v. This is imparted to all the points. Now, if I want to find the velocity of the point O, okay, total velocity of the point O due to the linear motion and due to the rotation. So in this case, this velocity is imparted, v velocity is imparted, okay, because velocity of center of mass is imparted to all of the particles. Now there is one more linear velocity due to the rotation. Due to the rotation, there is one more velocity, that is v is equal to r omega. We discussed now, there is one velocity v, there is a linear velocity is equal to r into omega. So v is equal to r omega, and this will be the tangential to the tangential. This will be the tangential to this point O, or you can say you will draw a tangent and point O with respect to this radius. This is the radius. Okay, you will draw a tangent, and now you can see here at this point, both the velocities are in same direction. So if the velocities are in same direction, velocity is a vector quantity. So same direction, if the velocities are, then the resultant velocity will be sum of v and r omega. Now at this point, the situation will be different. At this point, P, first the velocity of center of mass will be in this direction, that is imparted to point P. At point P, first velocity, you will say the velocity of center of mass and in this direction. Okay. Another will be the tangential velocity. Another will be the tangential velocity, that will be r omega. And when you will draw the tangent, the tangent will be like this. In this direction, there will be r omega. Now here, this is the tangent and this velocity is like this. So there is an angle of 90 degree, because this is the center of mass, and center of mass is the center of this disk also. If this is the center of the disk and this velocity is coming from the center of the disk, then it will be along the radius, and radius and tangent are perpendicular. So angle between this velocity v and r omega is 90 degree. Now here two vectors are at 90 degree angle. Two vectors are at 90 degree angle, then we will apply the vector law. Okay, velocity at point P will be the vector summation of this and this. That will be v square plus r omega square. At point M, first the velocity of center of mass, okay, imparted to this M in this direction. Now there is, due to the rotation, due to the rotation, there is one velocity in the opposite tangential direction, that is r omega. Now, at the point M, the resultant velocity will be v minus r omega, simply v minus r omega. Now, at point N, one velocity is v, another velocity is the tangential velocity, that is r omega in this direction. You will take the resultant, you will get this velocity. Now, we'll do one question. Have you taken the have you written this in the last class or not? Or you want to write this? Check your notes.
I have written it.
You have written, okay. So this question we will solve. This question we will solve, okay. So here is a disk. This is a disk, and this disk has some angular velocity of omega, rotating with an angular velocity of omega, and at the same time, the center of mass moving linearly with a velocity of 4 meter per second. Means this body is like this, rotating also and moving like this also. Means this will be like this also. This body is in the motion of the combination of the linear motion as well as the rotational motion. You can say general motion is there. Omega is given 3 radian per second. Velocity of center of mass is given 4 meter per second. This is given in the question, given data in the question. Find the speed of point A, B, C and arrange this and this. We have to find the speed of point A, speed of point B, speed of point C, and we have to arrange accordingly, either in the increasing or decreasing order. We will arrange. Okay. So now one by one we will see what will be the velocity. Okay. So I am taking this disk. Okay. So now first we will find the velocity of point A, or you can find the velocity of any point first, no problem. So at this point A, first velocity is the velocity of center of mass in this direction. Velocity of center of mass in this direction. This point will move with the velocity of center of mass in this direction. That will be 4 meter per second. First velocity is the velocity of center of mass at point A, that will be in this direction. Okay. After that, there is the velocity due to there is another tangential velocity due to the rotation, that is r omega. That will be r into omega. So here radius is given as 1 meter. Okay, so take radius as 1 meter because radius is not given here. So take radius r is equal to 1 meter. Okay. So radius is 1 meter. So there is one angular velocity, there is one tangential velocity that will be in this direction. At point A, there will be one tangential velocity in this direction. And that will be r omega. Okay, r into omega. And r is 1, omega is 3. So 1 into 3 will be 3 meter per second. Okay, so at point A, the net velocity will be 4 minus 3. That will be 1. So velocity at point A is equal to 4 minus 3. That is equal to 1 meter per second. Net velocity at point A will be 1 meter per second. Now at point C. Now C at point C. So at point C, the first velocity is velocity of center of mass in this direction. That will be 4 meter per second. Another velocity will be the tangential velocity due to the rotation that is in this direction. That is in this direction, tangential direction, like this. Okay. And that will be r omega. What is r omega? R omega will be 3. Okay. V is equal to r omega. And that will be 3. So in this direction, a velocity of 3 meter per second will be there. Now two vectors are at 90-degree angle. Two vectors are at 90-degree angle. So you will find the resultant. So resultant will be in this direction, like this. Resultant will be like this. So it will be 5 meter per second. How it will be 5 meters per second? Velocity at point Z will be the vector summation of velocity 4 meter per second is square, 4 square plus 3 square. Will be 4 square plus 4 square plus 3 square will be root 25. Root 25 will be 5 meter per second. Now another velocity at point B. Now we will calculate the net velocity at point B. At point B, first velocity is the velocity of center of mass in this direction. In this direction, so sad. It will be like this, okay? It will be like this. One velocity is, that is, this velocity will be imparted to B point. Now we are calculating for B. So it will be 4 meter per second. Now another velocity at this point will be 3 meter per second. And that is also in this direction, tangential direction. Okay? That is also in this direction, 3 meter per second. Now at point B, the net velocity will be 4 plus 3, 7. So velocity at point B is equal to 4 meter per second plus 3 meter per second, that is equal to 7 meter per second. Now at point A, at point B, at point C, we have velocity. Now we will arrange. They have mod of VA, means they are asking only magnitude. So we have only magnitude here also. So we can write maximum velocity is of velocity of point B. After that, the velocity of point C, and after that we have the least velocity at point A. First, to every point, give the velocity of center of mass in the same direction as that of center of mass is moving. Now, after that, there is one more velocity due to the rotation. And see, when you are providing that velocity due to rotation, okay, so you have to see the sense of rotation, and accordingly you have to decide the tangent. Okay. There is one more question that will be a good question. So now this question is given, this disk is at the same time is moving linearly with a velocity v and rotating with an angular velocity of omega. We have to find the velocity of point P, this point P, which is making an angle theta with vertical, and this is the center of mass with respect to the ground. So all of the velocity we were calculating with respect to the ground only. So we will see this question now. Okay, now at this point we want to find the net velocity. First, what is the meaning of the velocity at point P with respect to the ground? Means the net velocity at point P. So net velocity at point P, how you will find? Provide first the velocity of center of mass. So in this direction there is one velocity, that is this v. At point P there is the velocity of center of mass v in this direction, and another velocity will be the tangential velocity due to rotation, that will be r omega, and that will be in the tangential direction. This is the radius, and tangent you will draw like this. Okay, so this will be r omega, this will be r omega. And one more thing is given, omega is equal to v by r, they have given. So v is equal to omega r, we can write easily. So this is given in the question. So omega r is given. So if this is r omega na, so this r omega you can write r omega as v also. Now there are two vectors. This v is one vector, r omega is another vector, and they are acting at some angle, and we have to find the resultant velocity at point P, and that will be given by the vector addition of this and this. So we want to find this angle between the two vectors. Very easy. Talking about this angle, what will be this angle? This angle will be 90 degree, because this is the radius. Okay, because this is radius and this is tangent, and radius and tangent are 90 degree to each other always in a circle. So this angle will be 90 degree. Now find this angle. So if this angle is theta and this angle will be 90 degree, this angle will be 90 degree. So if this angle is theta, this angle is 90 degree, this angle will become 90 minus theta. So this total angle will become 90 plus 90 minus theta, 180 minus theta. So in this way you can draw the vector diagram. Means there is one velocity in this direction. So in this direction there is one velocity, in this direction there is one velocity. This is the point P. Point P is there, and in this direction there is r omega, and this r omega can be equal to, this is equal to v also, and there is one velocity in this direction, that is equal to v. That is equal to v, and this angle will be 90 plus, now this angle is 90 plus 90, 180 minus theta, 180 minus theta. Now two vectors are there. For the resultant of the two vectors we have the formula r is equal to under root of, or resultant square, r square is equal to a square plus v square plus 2ab cos of theta. Theta is the angle between two vectors. Now this vector is v, this vector is also v, both are acting at 180 minus theta degree. Now we will find the resultant. So it will be r square. Okay, so r is resultant square means resultant of this velocity and this velocity. This velocity means the velocity of net velocity at point P with respect to the ground, you can write this and the square of this, because resultant means the resultant velocity at point P. And what is the resultant velocity at point P? The velocity of point P with respect to the ground, net velocity at point P. And this is equal to a square means v square, and v square means v square. Means here a is this, you can take any one a, this is A vector, this is another B vector. Now 2AB, 2V into V means 2V square, and cos 180 minus theta. Cos 180 minus theta is minus cos theta. So it will become V square and V square. It will become 2V square minus cos 180 minus theta means minus cos theta. So it will become minus 2V square cos theta. Now you can take from here 2V square common. So you will have 1 minus cos theta. Now there is one formula, that is trigonometric identity 1 minus cos theta can be written as 2 sine square theta divided by 2. Okay, 1 minus cos theta 2 sine square theta by 2. So you can write this 2V square and it will be 2 sine square theta by 2, and here you will have velocity point P with respect to ground and square of this. This is equal to, this is 2 to the 4 V square sine square theta by 2, and now take the under root on both sides. You will get the velocity of point P with respect to ground is equal to 2V sine theta by 2. So this is the final answer. This is the final answer. Okay. Understanding? Vibha?
Yes.
Okay. So one by one, write down first the question and then the answer.
Done, sir. Done, sir. Done, sir. Done, sir.
Done. Okay. So the final answer will be 2v sine theta by 2 and 2v sine theta by 2, and this is the, I will say, an important question. Okay, can be asked in exam also. First thing, for any point, if you are calculating the velocity, okay, for any point of disk, not on the periphery, anywhere of the disk, it can be of sphere, it can be of ring, it can be of cylinder, any type of shape also. First, give that point the velocity of center of mass, and after that there will be one tangential velocity due to the rotation, and accordingly you have to decide the direction. Acco- Accordingly, okay, you have to decide the direction. Okay, so now we will discuss the acceleration. Till now we completed the velocity in the general motion. Now we will discuss the acceleration in general motion. Now it will be complicated, means it can become complicated. It is not complicated, means now you can see the body is rotating at the same time, it is moving at the same time, rotating also, moving also. Now there will be acceleration, and in the circular motion, sorry, just a minute. In case of the circular motion, I told you there are two types of acceleration. When the body is moving in a circle, there are two types of motion. And what is rotational motion? Different particles are moving in a circular motion. So for any particle, okay, that is moving in a circular path, there are two types of acceleration. Can you tell me the names of those two types of acceleration? Hmm? There is one acceleration due to change in
Tangential.
hmm, hmm, hmm,
Tangential.
tangential, and there is one more,
Centripetal.
centripetal. Huh? Two accelerations we discussed due to the rotation, due in a circular motion mostly. So whenever the if a body is moving in a circular path, if a body is moving like this in a circular path, always the direction of the velocity will change, because at each and every point you will draw the tangent to find the direction of the velocity, and each and every point there will be different direction of velocity, means there will be different tangent, so there will be different direction of velocity. So means always remember, whenever the particle is moving on a circular path, always there is a change in the direction of velocity. And if there is a change in the direction of velocity, if I am saying there is velocity, and velocity have one magnitude and another is direction. For example, if I am saying 5 meter per second towards north, 5 meter per second towards north. So this is complete description of velocity, 5 meter per second towards north. If I am saying only 5 meter per second, this is not the velocity. 5 meter per second will be the magnitude of the velocity, but not the velocity. It is speed. So you can say velocity have two things. One is magnitude, that is 5 meter per second in this case, and another is direction. If I am saying if a body is moving 5 meter per second along north direction, and after that the body sorry, after some time the body is moving 5 meter per second towards east, then will the velocity changes or not? Here the velocity is changing or not changing if the direction is changing. Listen once more. If firstly I am saying, firstly a particle is moving 5 meter per second along north, after some time the particle is moving 5 meter per second along west. So during the motion of the particle, is the velocity changing or not changing? Hmm? Direction is changing, na? First the particle is moving along north, then the particle is moving along east.
Yes, sir.
Means the direction of the velocity is changing. If the direction of the velocity is changing, means the velocity is changing. So for changing the velocity, okay, so we'll discuss first this thing. So velocity have magnitude, magnitude means speed, and another thing, it will have direction. Mainly it will have magnitude and direction. I am not saying it is have it also have unit also, it have also have dimension also. I am not talking about that. So velocity having magnitude and direction. Changing any one of them, either the direction or magnitude will change the velocity. Remember this point. If the direction is changing, then also the velocity is changing. If the magnitude is changing, then also the velocity is changing. And acceleration is change in velocity with time. If the velocity is changing with time, then there will be acceleration definitely. Now, I told you in a circular motion, direction is always changing. Direction always changing in circular motion. So if the direction is always changing in a circular motion, it means the velocity means is always changing, or at each and every point the velocity is changing. It means that if the velocity is changing, means there will be some acceleration. So that is why there is the acceleration during the circular motion. Okay, and that acceleration due to change in direction is known as the centripetal acceleration. If suppose the body is moving on a circular path with 10 meter per second speed, all the time the body will have the 10 meter per second speed. Then also it will have this centripetal acceleration. Why? Because due to change in direction, there is another acceleration due to change in magnitude. For example, on a circular path, if a particle is moving first with 5 meter per second, then 10 meter per second, 15 meter per second, means the speed is increasing. Due to that increase in speed, there is also change in velocity. There is also change in velocity, and due to that change in velocity, there will be some tangential acceleration. Okay, so I am taking again this point I am taking, and this is the velocity of center of mass, and this is moving linearly and rotating at the same time with an angular velocity of omega. And this is any general point where we want to find the sorry, this is not the velocity, this is the acceleration of center of mass. Acceleration of center of mass. So basically this body is rotating at the same time and moving linearly at the same time, and acceleration of center of mass is in this direction. We want to find the acceleration of net acceleration at this point in the general motion. So now first see, I told you that like velocity is imparted to each and every point, impart the acceleration to each and every point. So acceleration of center of mass is imparted to this point. Okay, first do this thing easily. So there will be one acceleration. There is one acceleration at this point, that will be acceleration of center of mass. Clear? Okay. Okay, this acceleration, if you out of this point you can take any other point also, then also this acceleration will be imparted to that point. Now this body is rotating also at the same time. Due to the rotation, this particle will perform the circular motion, and in circular motion there are two types of acceleration. One is centripetal acceleration toward the center. Toward the center there is an acceleration. For this point there will be one acceleration toward the center, okay, like this. Toward the center now there will be one acceleration, that will be centripetal acceleration. Centripetal acceleration toward the center. Now there is one more acceleration, tangential acceleration. For this point there will be one centripetal acceleration, I told you. Why? Because this particle is rotating in a circle. There, due to that rotation, the direction of the velocity is changing, and due to that there will be centripetal. Basically there will be centripetal acceleration, and there will be tangential acceleration also if the magnitude of the velocity is changing. Centripetal acceleration is given by the speed with which particle is moving, square of that divided by the radius of the circle in which the particle is moving. And tangential acceleration is basically rate of change of speed, dv by d mod v by dt. Mod v is basically speed, and ACOM is basically the center acceleration of center of mass. So there are three types of acceleration. One is acceleration of center of mass, another is tangential, another is centripetal acceleration. So three types of acceleration the point P have. So if this is a point P, so this point P will have first acceleration is acceleration of center of mass. Okay, another acceleration will be the tangential centripetal acceleration or tangential acceleration. Centripetal acceleration. Another acceleration is tangential acceleration. And we know that centripetal and tangential acceleration are perpendicular to each other. So both these acceleration will be at 90 degree, and this acceleration, this angle will depend upon the situation. Okay. So now both means acceleration is a vector quantity. So we can write this in the vector form like this also, like this. So net acceleration at point P is equal to the vector summation. Okay, you will do the vector summation. Acceleration of center of mass plus acceleration, centripetal acceleration plus tangential acceleration. Accordingly, add and you will get the answer. One more question we will do. One question we will do on this. Okay, simply. Then you will understand what I want to say. This is a disk. Center of mass has the acceleration of this 5 meter per second square. This disk is rotating with an angular velocity of omega. Radius is 1 meter, and omega is given 3 radian per second. And what is asked? Alpha is asked. No, alpha should be given. A is equal to R into alpha. Take alpha as 4. 4 radian per second square. Alpha is also given. We have to find the net acceleration. We have to find the net acceleration at point P. Okay, this point P at point P. Okay. So what was the procedure I told you to find the net acceleration? Impart this acceleration of the center of mass. Acceleration of center of mass is 5 meter per second square. So first impart this 5 centimeter square 5 meter per second square in the same direction to the point P. Okay, so this will be the first acceleration, that is 5 meter per second square. Now there is another acceleration, centripetal acceleration at point P. There is another centripetal acceleration. Okay, and that centripetal acceleration is equal to v square by r. Okay, and this is also given by r omega square. This is also given by, there are two formulas of the centripetal acceleration, v square by r and r omega square. When you will put v is equal to r omega, you will get this formula. So centripetal acceleration we can find from here. R is 1 and omega square means 3 square. 3 square means 9. So we will have 9 meter per second square. Means in this direction you have a centripetal acceleration of 9 meter per second square. Now there is tangential acceleration. There is one more tangential acceleration, and that tangential acceleration will be in the same direction, in this direction, because this is radius and this is tangent. And that tangential acceleration, I told you there is a relation between tangential acceleration and angular acceleration r alpha. So tangential acceleration we can find with this. R is 1, alpha is 4. So 4 meter per second square is tangential acceleration. So in this direction there is an acceleration of 4 meter per second square. Now net acceleration. Now see at point P. In this direction what is the net acceleration? 5 plus 4, 9. In this direction 9. Okay, now at point P, draw the diagram, vector diagram separately. So suppose this is a point P. At point P, this is a point P. Okay, this is a point P, and at this point P, the acceleration in this direction is, total acceleration in this direction is 4 plus 5, that is 9 meter per second square. Now in the central direction, means in this direction, the acceleration of 9 again. And what is the angle? This angle will be 90 degree, yeah? Because this direction is tangential direction, this is radial direction. So this angle will be 90 degree angle. Now vector summation, do the vector summation of this. So if you want to find the net acceleration at point P, net acceleration at point P, that will be the vector summation of this and this. That will be 9 square plus 9 square. That will become 9 root 2 meter per second square. Write down. From here, write down. So in general motion, there are three types of acceleration at any point. Okay, we can write here.
Done, sir.
Done. Okay. So add one more point. Three types of acceleration are there in general plane motion. Add this also, this point also. Done.
Done, sir.
Uh,
Done, sir.